So here we want to calculate the final angular velocity and then the initial kinetic energy, final kinetic energy. We know that the mass of the person is going to be equal to 75 kilograms. We know that radius is equaling 3.0 meters. The moment of inertia of the merry-go-round is going to be equal to 820 kilograms per meter squared. And we can say omega initial equals 0.95 radians per second. Now, we know that we can solve the omega final, the final angular velocity, by using the conservation of angular momentum. So L initial equals L final, and we can say that I initial, omega initial equals I final, omega final. We're trying to find omega final, so we can say that we can further define this and say I of mgr times omega initial will equal the moment of inertia of the merry-go-round plus the moment of inertia of the person times the final angular velocity. So omega final is going to be equal to omega initial, the moment of inertia of the merry-go-round, divided by the moment of inertia of the merry-go-round plus the moment of inertia of the person. We know that the moment of inertia of the person is going to be mr squared, m sub p r squared. So we can finally find the final velocity, final angular velocity. So final angular velocity would equal 820 kilograms, the moment of inertia of the merry-go-round, times 0.95, the initial angular velocity, divided by 820 plus the mass of the person, 75, times 3.03 squared. And so we can find that this is going to be equal to 0.521 radians per second. So this would be your answer for part A, the final angular velocity of the merry-go-round. And then we can say that for part B, we want to find the initial kinetic energy. So kinetic energy initial equals 1/2 of I mgr omega initial squared. This is, we can substitute directly and say 1/2 times 820 times 0.95 squared. And this is giving us 370 newtons. Sorry, my apologies, 370 joules. Then kinetic energy final would be equal to 1/2 times the moment of inertia of the merry-go-round plus the moment of inertia of the person times omega final squared. And we can say that this is going to be equal to 1/2 820 plus 75 times 3 times omega final squared, so 0.95, rather 0.521 squared. So this would be, again, the moment of the final angular velocity that we found in part A, 0.521. And this is equaling 472 newtons. Joules, my apologies. So this will be your final answer for the final kinetic energy, and this will be the final answer for the initial kinetic energy. And then this would be, of course, your final angular velocity. That is the end of the solution. Thank you for watching.